Hi everyone, in today's class, I'll explain what are partial fractions. A rational expression f of x by g of x is called a proper fraction when if the degree of f of x is less than the degree of g of x. That means if the degree of the denominator is greater than the degree of the numerator. Now, during this time, g of x can be factored into real factors and quadratic factors without real zeros. That means this rational expression f of x by g of x can be expressed in simpler forms. How in simpler forms? By factorizing the denominator g of x. Okay, that simpler forms are said to be partial fractions. When you express this f of x by g of x into simpler forms by factorizing the denominator g of x, then that simpler forms, what you are expressing, no, they are said to be partial fractions. Let us see one example. Now, what is 1 by x square minus a square? That is a question. Resolve into partial fractions. What is the degree of the numerator? 0, because no x terms are there. Degree of the denominator is 2. Okay. Now, we can factorize the denominator. X square minus a square is x plus a into x minus a. Because we have the algebraic identity a square minus b square is equal to a plus b into a minus b. So I am using that algebraic identity. I am factorizing, okay. So a by x minus a plus b over x plus a. Okay. Now what is the LCM? X square minus a square. If you multiply all the terms by LCM, I am getting 1 is equal to a into x plus a plus b into x minus a. Now I am doing simple multiplication. Ax plus a into small a plus bx minus b into small a. Okay, I am comparing the coefficients of x. X. Here no x terms, no, so 0 is equal to a plus b. I am comparing the coefficients only, no, okay. This is first equation. Now comparing the constants. What is the constant here? 1. 1 is equal to a into small a minus b into small a. Okay. Now, this is the second equation. I am multiplying the first equation by a. So, what I will get? 0 is equal to a into small a plus b into small a. I am adding these two. So, this will go off. 1 is equal to 2a into small a. Okay. Now, substitute 1 is equal to, capital A is equal to 1 by 2a. Am I right? Capital A is, this implies capital A is equal to 1. Okay, in first equation, if I substitute, what is the first equation? A plus b is equal to 0. No, if I substitute there, I'll get b is equal to minus 1 by 2a. So, I can express this 1 by x square minus a square as two fractions. First fraction is 1 by 2a into x minus a plus, what is b value? minus 1 by 2a, no? So minus 1 by 2a into x plus a. See, if you add these two fractions, you will get this 1 by x square minus a square. This procedure can be carried out if the denominator has all its zeros in R. Okay. Suppose if the denominator is x square plus a square, during that time, this x square plus a square does not have real zeros. Am I right? We have to do in other methods. I'll explain that method in my next video. Thank you.